Okay, cool. So basically, I think a common thing that you want when you're writing a program is you might have a bunch of thermometers and say that's a class you're using. You're going to connect to the thermometers. You're going to get data from them, disconnect. But you have different types of thermometer, right? You have maybe one that like communicates with Modbus, or like one that's like I2C, different types. So you have different types of these classes, and you want your user to be able to configure it, you know, for each system. Like, oh, on this one we have 2 I2Cs and 1 Modbus, or whatever it is for that system. So here we're going to do that. Oh no, what have I done? What? Oh, okay. I apparently need to make this modal, yeah. But anyway, so we'll do a Modbus thermometer. I've added like 5 now. And we can set like an IP address for this. And then we'll do another one that's I2C, and we can set a COM port. So the cool thing that you can see about this is like these are both different children of a common thermometer base class, and they both have a name and a color. That's in the thermometer base class, so they all have that. So we could kind of give them a different color. But then this part is a part that's different depending on the type, because they may have their own different configuration. And then we can start getting the temperature from these thermometers, show it on our graph, and there we go. Great, so this is what we want to have. So now I'll show you like how do we get this. Okay, so what we want to be able to do is save and load different types of classes, right? The 2 different types of thermometers. And we also want to have a tiered configuration. So what I was showing you, this part is shared, and then this part is more specific. And potentially maybe we want more than 2 tiers, like multiple different tiers. The other thing that I wanted in this framework is, if possible, I'd like to not make it so that all my objects that are configurable have to share a common parent, because in this case, my thermometers are just objects and I'm just using them within my code, but I might want to have something that's configurable that's actually an actor, or that's, you know, inheriting from some different object. So I don't want to be forced that all of my objects have one common parent. So those are the goals for this. So you can get the code that I'm using for this example and for the framework here if you want. It's on GitLab. I just made a public repo. I don't know if this Chrome QR code will work. You can try it. Yeah, good. I'll try to put this up again at the end. You can remind me. So the other thing about this presentation is like the way I'm doing it, I'm using actors because I always use actors all the time. And I'm using panel actors as well, which is like MGI's open source extension to actor framework. So if you don't use actors, this presentation can still be useful for you, because you don't have to use actors to use this type of framework that I'm talking about. You could use it with whatever your version of actors is in your framework. But just so that we're at least on the same page, so you can kind of understand, if you don't know what actors are, it's basically an object that can run asynchronously, and it can respond to and send messages. And then a panel actor is a type of actor that has stuff in it that makes it super easy to just put the actor core front panel into a window or into a subpanel on demand. Okay, so this is our starting point. This is where we might, if you're like writing a basic program, we're like, okay, we're gonna connect to our thermometers, we're gonna like start getting some data from them and graph it, and then at the end we'll disconnect. But kind of the question is, okay, well, how do we get those thermometer objects? If we're gonna load them from file, or if we want the user to type them in the UI, how are we gonna get them? So here's the answer. I'm going to split that thermometer into basically 2 objects. So one that's, can you see my mouse? Yeah. So one that's the thermometer itself, that's going to do all of that logic, like doing the connection, doing what it needs to get the data. And then a second one that's just in charge of the configuration for that thermometer. And so the thermometer is going to be what's called a configurable interface. And then the config is going to be the configuration. So the thing that we have that we wanted here is our thermometer can have any inheritance hierarchy that we want. Whatever, if we want it to be an actor, if we want it to be something else, and then it can still inherit from this configurable interface. And then what we have over here is the thermometer has a thermometer configuration. The configuration is going to be what actually specifies this is the data that the thermometer needs, and here's how that data gets serialized. So this class here, the configuration class, it has to implement a method for like how to take that data and put it to JSON, or how to read it from JSON. So you guys are probably asking, like, this has a relationship, like, you know, why is that not here? Like, we want all configurables should have a configuration, and like ideally that's what I want. All configurables do need to have a configuration, but unfortunately interfaces can't have class data. So basically I'm just forcing you to do it yourself. So I have these two methods here, setConfig and getConfig, and they're required override in the configurable. So I'm basically just saying anyone that inherits from the configurable interface, you have to override these methods and store the configuration in your private data. Does that make sense? Any questions about that? Yeah?
Create configurable has a dramatic music, my question.
So create configurable, is that a static method for each instance of configurable, each child class of configurable?
Yeah, so create configurable is the constructor, and it's not dynamic dispatch. I guess constructors usually aren't. So the create configurable method, I can just show you that. Well,
okay,
actually,
so that's,
I was going to show you later, but basically what it does is it takes in a configuration.
that's just the parent abstract.
Yeah, but it's not dynamic dispatch. You don't override it. It does everything for you. What it does is it takes a configuration and it gives you a configurable. And it's going to give you a configurable that matches the configuration. Does anyone know how do you make it go from the slide you're at?
Shift F5. Yeah.
Oh, okay, good. Yeah, so so for example, if I have an I2C thermometer config and I use the create configurable and I put this in, it's going to give me
the right one back. Okay.
Wait, it's going to give me an I2C thermometer. So it'll give me the matching type for what I want. But I don't have to know what's going on, right? So if I load this config, I can just say, hey, give it to me as a thermometer. And all I have to care about is that it's the thermometer. I know deep down inside it'll be the right one that I want for what I'm loading. Any other questions? Okay, cool. Yeah, so these are really the only methods that our configurable has. And then as for the configuration, like I was telling you, there's a from JSON and a to JSON. So that's where you define how it gets serialized. And really, you could do this for like whatever, an INI file or XML or whatever. I just did JSON because that's what I like. So it has that. I'll explain more about this core thing in a minute. And then all configurations, usually you just have a config cluster and put that in the private data. That's its configuration. And you'll want to make accessors for the stuff that's in the config cluster, just so that it's easy to access. In this case, I just added a GUID to all of my configurations. You don't have to, but the GUID is basically just a unique ID. So that way I can always, if I have a configuration, I can always uniquely identify it. I always know who is who. In case, for example, they had the same name, they'll still have a unique identifier. Yeah, so here's the question of like, why do we have a separate class for the configuration and the configurable? And also, why is configuration a class and not an interface as well? I guess just like Stephen Loftus-Mercer told me that was a bad idea. But it's actually important because, so here's an example of what the JSON looks like. And you can see that it's tiered. So here's all of the thermometer configuration. And then here's the Modbus thermometer configuration. And it basically, every level of the class needs to be able to serialize itself. So I wouldn't want someone to create a configuration object that was inheriting from something else that couldn't serialize itself. So I basically forced you to inherit from the configuration class, which can serialize itself, and then you're forced, every layer down has to be able to serialize itself. Yeah, and the other thing about this is, so there's a section for each class, and then there's also a section at the top called the type, and that I just put the name of the class, so that that's how I know which class to load when I'm loading this from file. I guess it could be an issue if you renamed your class, your configuration files wouldn't work anymore, but I would just say don't do that. Okay, so here's how from JSON works. So this is where I'm reading that type, and then I'm literally just creating a LabVIEW class from that. And then this is the from JSON core method. So from JSON is static dispatch. It's not dynamic dispatch because I don't even know what class to wire in, obviously. So that's why we have to have this core that is dynamic dispatch. Once we have created the class, then we can actually, then that class can run and it can start unserializing itself from the JSON. Does that make sense? Any questions about that? Yeah?
Why did you just use the built-in XML serialization for classes so you didn't have to define how to serialize it from JSON?
Yeah, for me, I like to do it manually just because then I have more control over what's going to happen if I make a change to that class. So for example, let me show you the from JSON core for one of these. Yeah, here we go. So here's my from JSON core. So what I'm doing is here, I keep track of the version. And so that way, so for example, in version 1 of this, I didn't have a color. I didn't have a color, and so I was just using the name. And then in version 1.1, I added the color. And so I like to be able to manually do this because let's say for some reason I thought I could predict what color it should be from the name. I could add something here to say, okay, this was before we had this separate color thing, but I think I can guess what color the user wanted it to be from the name, or something like that, right? I have more freedom on, if I've added a new field, what that default value for that new field is going to be, if I'm reading an old file, or something like that. Or maybe I previously had two fields, and then I'm changing it to one field, but I can figure out what that one field should be from the old 2 fields. I could do whatever I want with that. So it's kind of nice. And what I'm using here, this JSON class, this is a GPM package. I think it works pretty well for doing JSON. It's like a JSON class, and then you can get, all the different sections of it by name. Any other questions? Okay. Wait, you said Control Shift F5 or Shift F5?
Or right next to the bottom right-hand corner where there's a slider.
Oh, there we go. I guess okay. Okay, yeah. So here's how you would create a configuration, right? So as a user, I was creating one. by clicking this add arrow, right? And then I was picking one, and it was creating a new one for me, right? So here's how we do that in the code. So here I'm using this framework. This is part of the configuration framework, this VI, which says get configs by type. Basically what this does is I'm saying, give me a thermometer, give me all of the configuration types that are a type of thermometer. So it's going to give me here the Modbus and the I2C. So it's going to give me those two types. And then here, this is a configuration VI that just gives you a dialog. So give it the two types, and then it will just show you a dialog and let you select one, and then output it here. And then I'm just kind of initializing it, giving it a GUID, and like initializing it with like a default name. You could put other default data here if I wanted to give it a default color or something for my use case. And then here in my actor, I'm basically just keeping track of my configured thermometers. These are my thermometer configurations. So I'm just adding it to that list that I'm keeping track of and doing some stuff to update the UI. And I'm saving it to file. So that configuration will be saved now. And if I were to close the VI, if I were to close this and reopen it, it loads everything just like I had it. So. Okay, so now that I have the thermometer configuration that the user has selected, how do I actually get the thermometer object, right? Because remember, this here is just a configuration. It just has the data that's needed, but I'm also keeping track of these actual thermometers. These are what I'm actually going to be using. So as the user, let's just keep this running. Let's see. So when I make an update to the configuration, like say I change this color to blue or something, or I'm saying like refresh from setup, and this is where I'm recreating my objects, I'm reconnecting to everything to start to use them. All right, so when I click that button, basically what happens? How do I go from the configuration I have here to these actual objects that are doing the operation down here? So how I'm doing that, the first thing I'm doing is just, these are my old objects, so I'm disconnecting from them if needed. And then I'm creating my new ones. So I'm using this framework VI called create configurable. That's the one I was showing you before. I'm taking my configurations. I should have made these a different color wire because these are configurations, these are configurables. I'm taking my configurations and I'm putting each one in. I'm saying, hey, create me a configurable from this configuration. And then it's creating my configurables. And see, right here, like I'm just saying I'm going to treat them as thermometers. I don't care what kind they are, because from my perspective, it's the same. But, you know, deep down in its bones, this wire knows that it's a Modbus thermometer configuration. And so here it's going to give me a Modbus thermometer. I'll treat it like a abstract thermometer. And then I'll just connect to all of them and save them back in my private data. Any questions so far? Okay, cool. So we'll just go back to our picture again. Hopefully you understand the configurable and the configuration. Configurable has a configuration. I didn't want to confuse you too much from the start, but there's actually a third thing that we have, and that's the setup screen. Right, so I told you this does the operation. This one takes care of the data and the serialization. This one is actually in charge of the user interface, so what it looks like for the user when they're going to be configuring it. And the reason that this is separate from like just doing it here is, like I said, in this case, these are just objects, I'm just using them. But these could be actors, and if it was an actor, maybe it has its own UI that's part of the operation that it's doing. So I want to be able to have a separate UI where I actually specify the configuration itself and how that's done, sort of separate from the actual operation. So this is my user interface thing. It's called a setup screen. So in my case, it's a panel actor. If you were going to be using this framework in like a non-actor framework context, I guess you would have this be whatever your version of actor is. So you'd make your own setup screen, and maybe it's an SMO object or whatever you want it to be, whatever is easier for you to handle. For me, definitely panel actor is easiest, and you can see it just has the same sort of hierarchy. The thermometer has a matching thermometer setup screen, and each of these has a matching setup screen. Okay, so what methods does the setup screen have? Well, it's an actor, so in its actor core, that's where we actually put the UI for how you set it up. And then it's an actor as well, so it uses messages. So it has this config update message. That's where it can receive updates about its configuration. And it also sends those messages as well to send them to other people. You might be wondering if it's doing its own configuration here, like why does it need to receive updates about the configuration? And that's mostly just for convenience. So I'll show you an example, the thermometer setup screen. The way that we structure this is, okay, so first here, I'm creating a panel tier. And this is a feature of panel actor. But basically what I'm doing is I have a sub panel on the front panel here. And so I'm taking that sub panel and I'm just saying, hey, if I have a child, oh, what is this? If I have a child and my child has an actor core, put that child's actor core in this sub panel. And if I had a child that might also have a child, then that one could also have a sub panel, so it can go however many layers deep. And then what I'm doing in here is basically, if the person changes the name or the color, then I'm updating it in my data, and I'm sending that config updated message that I was telling you about. The other thing I'm just doing kind of for convenience is I'm also subscribing to that message. And you could say, well, maybe this isn't necessary to subscribe to the message because, well, I mean, I know it happened here, so I don't need to necessarily tell myself it happened again. But I just do it because, I might, for example, if in here the IP address changes or something, I want to know about that, and I'll want to keep this up to date. So I would get that update here that the IP address changed. I'm not really doing anything about it, but I could if I wanted to. I mean, yeah. So it just keeps it up to date. And that way, like, you don't want to have a bug where, the IP address changes here, but I don't know about it in here, and so then I change the name, and it overwrites what that IP address was changed to. So basically, everybody gets kept up to date with the new configuration changes because of this config updated message here. Okay, so now I hope we're not getting too crazy for you guys, but it turns out the setup screen is actually also a configurable because it also has a configuration. So it's also configurable. You set the config and you get the config. And that means you can create a setup screen in the exact same way you would create the thermometer themselves. So here's how we're doing the this part, right? So when I click on one of these, I show you the setup screen for it. If I click on this one, I show you the other setup screen. Here's how I'm doing that. I'm basically, so if I previously had another setup screen, then I'm stopping that. Oh, wow, here's a great example of actually clearing the error, like not just relying on automatic error handling, because I want to be explicit. I may not have a setup screen that's already running, right? Maybe it's the first time I'm setting one up. And in general, I don't like to check if the enqueue is valid and then send the message because, I don't know, maybe it became invalid between when I checked and when I sent it. So in a case like that where I'm sending a message to someone that I'm not sure if I have a valid enqueue or not, and if I don't, then I don't care, the message doesn't get there, right? I just clear the error I just send it and clear the error afterwards. But I also, in this case, I wanted to make sure that I stop it before I start the new one. So I just, I guess maybe it's silly to merge an error that you just cleared, but that's just for data flow. Maybe it's not, I could use a sequence structure or something. I mean, maybe it's not necessary, actually. I guess I could stop it at any time. Anyway, I'm stopping it. And then I'm using the create configurable. Remember the same thing that we were doing before, only this time I'm saying it has to be a setup screen. So I'm taking the same configuration for my thermometer, but instead of saying give it to me as a thermometer, I'm saying this time give it to me as a thermometer setup screen. So instead of giving me the actual object that can do the operation, it's going to give me the actor that can just show the setup to the user. So I just take that actor, and then, yeah, like if you're not familiar with panel actor, I'm launching this as a nested panel, and I'm just saying put it in this subpanel. The subpanel I have for that is just here. This is the subpanel that I'm putting it in. So I just stored the reference to this subpanel in my private data so that I have that there. I just insert the actor into that subpanel. Okay, so about how, just a little bit more about this send config update message. It's an interface because that's the new way we do messages. In a previous version of this framework, before interfaces, we actually at MGI started making this framework before interfaces, and so we were using malleable VIs to sort of get interfaces, and then we were using abstract messages, but that's the thing of the past. So now we have this interface called config update receiver. So all setup screens are inheriting from config update receiver. But then if you want to get updates from your setup screen, then you should inherit from this as well. And it'll automatically send updates to its caller. So if you're the caller, just inherit from it, launch the setup screen, and you'll automatically get those updates. So yeah, I guess I'll show you that here. So this main actor here, it's inheriting from that interface. And so this method is actually the override. You can see I don't actually have a message for this here. These are more my internal messages. To be honest, I should probably mark these private, actually. These are all internal. What do you access go? Anyway, I'll do that later. Anyway, these are all internal. But this one here, you don't see it here. That's because it's actually implemented here. The config update message. But yeah, so all I had to do is just override this VI here. And then what I'm doing here is I'm taking my configuration. In this case, the only thing that I'm trying to configure is thermometers. So I'm just casting it to a thermometer. But in other cases, you might have multiple things that you're configuring. So you would probably, cast it to different things, and based on whichever one works, then you would update the correct thing. But in this case, I just have the one. And then what I'm doing here, this is kind of why it's nice for me to have the GUID, because then I can know, right? I don't know which configuration I'm getting the update for, but I know it by its GUID, so I can just check it against all the configurations that I have, and then I'm just replacing it, the one that I was getting the update for. I'm just replacing that in my private data, and then I'm updating the UI so that it will reflect the new thermometer. Yeah.
Yeah. So you have the receive message separate from the configurable. Is that correct? So a configurable could not necessarily implement the receive config.
Yeah, so a configurable doesn't necessarily need to be an actor. So
so the configurable, that's not an actor, that's just okay.
Yeah, it doesn't have to be, and in this case my thermometers aren't actors. So not all configurables would necessarily need that message. But all setup screens do need it. So it is part of if you're inheriting from setup screen, you've already inherited from that interface, because that's a part of setup screen. But yeah, here I can show you update UI. Basically, all I do in update UI here is I just take the names of my thermometers and like set that list box. So you can see basically if I change the name of a thermometer, then I'm going to get this update message here. I'm going to update it in my private data, and then I'll reset the name of the list box. So you can see that working here. I'll prove that it works. There we go. Amazing. It updates. Yeah. Any other questions so far? Great. Okay, so there was a little bit of secret sauce too that I didn't really quite explain to you, which is I kept saying stuff like there's this framework VI, and if you tell me that you want a thermometer, I'll give you all the different types of thermometers that exist, right? Or I'll give you all the different types of configurables. Well, how do I do that? It's not really magic. You actually have to register them at the start of the application. So in my setup screen is where I usually do it before I launch the actor. I'm just registering all of the types that I have, and it's actually just storing them in a global. Maybe it's bad, but it is a write once, read many times global, so I think it's okay. But yeah, I'm just storing, as I said, setup screens and configurables are both actually just configurables, so I'm storing those here, and then I'm storing my configurations here. So you just set them here. Yeah, and then the other secret sauce that I started to show you, but I didn't want to get too far into, is, where's the configurable? How does the create configurable work, right? How does it know which one matches? Because it's pretty fancy, right? If I give it a setup screen, it gives me the Modbus thermometer setup screen that matches my Modbus thermometer configuration. If I just tell it, give it to me as a thermometer, it gives me the Modbus thermometer that matches. So how does it know what matches? Well, what it does is in this set configuration, I told you that the set configuration was just for the purpose of forcing the interface to have data, and that is part of its purpose. I force you to store that data in your private data because the interface doesn't have private data. But it also has a little secondary purpose. When you store that information, so you're storing it in the private data, right, here. But you're also typecasting it to the version that matches for you, right? This one's typecasting it to a thermometer config. This one's typecasting it to an I2C thermometer config. It's declaring what type matches for it. So if it doesn't match, you'll get an error in this method. So that's all I'm doing here is I'm just trying everything until I get one that doesn't have an error. Then I know that's the one that matches. I think this is actually similar to what Casey was talking about in his presentation. It's sort of for a different purpose, but it's the same idea of like checking, hey, do you inherit from this interface, or do you inherit from this? Well, in this case, it's do you use something that inherits from it, but yeah. So that's that. And then the last thing, so here's why I don't think it's bad that you have to register all those types beforehand. I actually think it's kind of a feature, is you can actually make multiple setup screens if you want. So, right, this is my setup screen here. But let's say I wanted to make like a cheaper version of my product. I was going to sell it for a cheaper price and like a more expensive version. All I might have to do is just make two different setup screens. And in one of my setup screens, I'm like, oh, you can't do Modbus. You can only do, also, I think I got that wrong. I was changed stuff. But basically, I could make a setup screen where I don't let them do Modbus. You can only do I2C or something. So you can basically really easily dynamically decide what features you're going to allow and not allow. But you don't have to have all the complexity of like a full plug-on or a full plugin framework. I'm not doing weird stuff with plugins. Everything's statically done here. But it's just you could make a separate setup screen that puts in, separate allowable configurables. Yeah, so that's basically all I have. So I hope maybe you guys have some more questions. Yeah, Norm.
No other questions? Which one first? Go ahead, he's first.
Oh, I'll just give you a little backup on this. I'm doing something rather similar for a customer of mine where he's got about 1 billion different instruments that had to have configurations and some sort of configuration management tool and blah, 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 all the stuff that we're doing. And I came up with something similar to this. I'll talk to you about some of the details later. But yeah, this is good stuff, which is basically what I want to say. And while we did that before interfaces were available, and I finally got him off of 2016 out of 2021. So I'm going to look at your example and well, I guess it's not stealing if you give it to me. So
Yeah.
good stuff. Good stuff.
Great.
No other questions? All right. It's kind of secondary, but this idea you have a collection of your configurables, right? And that's you're storing them just as a basic array. And it just seems like I'm always eager to try to where are those opportunities to use a set? So it's totally like I said, it's off of this. But since no other questions, did you configure that, or since you are collecting things and referring to effectively a registry of things, did you consider using a set as that mechanism for storing where that is, or did you not? Because here's a really good reason why not to do that.
So I didn't really think about using a set. I guess the advantage of a set versus an array, I guess, is that it forces elements to be unique, right? And in this case, I just care about the type. So if there was such a thing as a set that would force the type to be unique, then I guess that would be cool. But I think a set wouldn't really force uniqueness in my case, because like I said, I'm only caring about the type, so it would still be possible to put 2 different Modbus thermometers in that had slightly different class data, which I only want to have one of each base level class type. Yeah, Steven?
So I'm currently working at Microsoft, which is where Derek's my tech lead now.
Yeah, okay, so I sort of stole it from him. Actually, he abandoned it in my hands.
Yes,
So it's fine.
but we're using something very similar for all the Microsoft design, and it does work quite well. The different layers and the panel actor, which is all open source and everything, has been really nice for UI design. Just on top of all the configuration stuff that Hope is highlighting here, the panel layer is also very nice to work with. So I'm glad you're showing this off here. If you did want to have a set that only has one item per thing, you can run it through a 0 element for loop to reset all of the objects as they come in to their default value, and then shove them into the set.
Yeah, that's a good idea, actually. Yeah, maybe I should add that. That also kind of reminds me of, there is a slight one thing that can, I think it's bad, but I'm not sure how to fix it. So I showed you this sort of hierarchy, right? So imagine there was a second inheritance here. Imagine this had 2 children. Or, well, wait, am I thinking about this wrong? Basically, it will pick the first thing that works. So you don't want to register, a thermometer. Because if it realizes that the thermometer works, it'll just give you an abstract thermometer. Or if this one had 2 children, you don't want to register this one, because then you'll get something that is abstract. Because it will, everything that you register, it'll loop through all of that, and if it gets to the thermometer and the thermometer passes, because it's more abstract than is needed, it will give you that. So you do have to be a little bit careful about that. You don't want to get objects that are too abstract out of your framework. Yeah, Quentin.
Well, this isn't a question. This is more of another endorsement. So, Panel Manager came out from a lessons learned on a big project that MGI was working with me at Hill Air Force Base, and ever since it was created, I've used it on my last 4 projects, and it's awesome. So, you need to look up Panel Manager, especially if you're doing Active Framework. Although there is a non-Active Framework part. If you're not doing Active Framework, there's also examples for DQMH and other things. So
Yeah. I definitely like if you already have a framework that you're using and you want to, use this, like I said, you can. You just have to make your own setup screen that's not an actor and that's something else. But I would heavily encourage, if you are going to use it, just start using panel actors because they're great and they're super convenient. So, yeah. Any other questions or comments? Yeah.
The collection extensions package that I showed this morning has a node that'll create a 0-element map based on types that you wire into the initialize empty map. And it uses a malleable VI to do that, yeah.
Oh, okay.
I think you were kind of mentioning that, Stephen.
So, or it creates a map of the right type?
Yeah, so you can wire in the data types of your keys and your value of your key and your value, and then it initializes an empty map. Yeah.
Yeah, that's kind of convenient because I always you have to make that map constant and it's big and you have to put it in and it's so big. Yeah, that's super useful. That kind of, was I going to say something else? Oh, I don't remember. Any other questions or comments? Yeah.
Is it available?
Yeah. Oh, yeah. So let me put that back up. Yeah. I just I don't have a package or anything for it, and honestly, the framework itself is not a whole lot of code. But I put it here on GitLab, and basically, honestly, the framework itself is just the configurable, the configuration class, the message interface, and like those couple of VIs like create configurable. Oh, you know, I need to move that. It's not in the right place. And the setup screen. So yeah, you can get to this in GitLab. You could make comments on it or pull requests or something. And this, I did just write this in 2020 because it uses interfaces, so I guess I couldn't write it earlier. Don't do a pull request in 2021 because I probably want to keep it in 2020. But this is something I hate about LabVIEW. So since I have time, I guess I'll just complain about it. Like, I love it when people make pull requests, right? Like it's the best thing in the world. Like it makes me so happy because we're doing good as a community. Like several people have sent like several pull requests for my like open source projects that I maintain, especially like pain relief. And they're good additions usually. Like they're good additions, but I think a lot of people, especially if you're not a consultant that works for a bunch of clients, you don't have LabVIEW's 2015 through 2020 installed on your computer, obviously, because like, why would you if you're a normal person? So like these normal people try to submit these pull requests and they're like, hey, like I didn't have 2015 on my computer, so I just did it in 2020. But then I basically have to look at their pull request, rewrite it completely in 2015, and then approve it. And it's super annoying. It messes up community engagement. So NI, you should fix that or something. But yeah, I usually like to keep something in an older version so people using older versions can use it. But this is in 2020 because, yeah, obviously it couldn't be earlier. Yeah.
Okay, so 1, feedback heard. 2, there's 2 questions on that one. If LabVIEW, when it opened your project, recognized what version you had saved it in and then offered to save it back into that same version, would that solve the problem you're getting at?
If when it saved it back, it just like perfectly saved everything in the right place and it didn't do that weird thing where like
right, linker
it
doesn't
does
change
program
anything.
Files for some reason and stuff. Yeah,
Right.
I guess that would solve it. Yeah.
Okay, so that was part 1. Part 2, you mentioned on your repo that you don't have this whole thing in a package that you can deploy to people. My question is, why not?
Partly just because I was, I was like making it, or I put it in here last night. But I guess also like, I don't know. I don't want to put it in VIPM because I want to put it in people's project level. I didn't know about Dragon yet. and I guess it's not out yet. And I don't know, I didn't want to put it in GPM because only Compose systems and us use GPM, so yeah.
Thank you.
Yeah. Any other questions? Okay, great. I guess we'll end a little bit early. Extra break.